Hello friends, I welcome you to my YouTube channel Make PM. So in this video we will solve a numerical problem which is based on metacentric height and stability. So I will suggest you to please watch this playlist from video number 1 so that you can have better understanding. Okay, a rectangular pen tool 10 meter long. Okay, so let's note down the parameters also. So L is equal to 10 meter, 7 meter broad, so this width is 7 meter, or B is 7 meter, and 2.5 meter height is 2.5 meter deep. Width 686.7. so W of this rectangular, so WR we can write is equal to 686.7 Newton, kilonewton. It carries its upper deck empty boilers of 5 meter diameter. So D of boiler is equal to 5 meter, weighing 588.6 kilonewton. So W of boiler is equal to weight of boiler is 588.6 kilonewton. The center of gravity of the boiler and the pentone are at their respective center. Means its center of gravity is at center of this rectangular portion, and the center of gravity of this circular or cylindrical portion is at its center of gravity, original center of gravity. Find the metacentric height, weight, height. We have to find metacentric height, so we have to find GM. Okay, now second thing is weight density of seawater is 10.104 kilonewton per meter cube. So this is weight density of water. So W of water is equal to 10.104 kilonewton per meter cube. So what is W? W is actually rho into G. Okay, this is called weight density. Rho is density and G is acceleration due to gravity. So suppose we are choosing a common point at A to calculate distances from here. So what is the center of gravity of this portion, rectangular pentone? So its center of gravity will be at, this is height is 2.5 meter, so 2.5 divided by 2 is equal to 1.25 meter. Okay, so from A it is AG1 is 1.25 meter. Similarly for this portion, what will be the AG2? It will be equal to 2.5 meter plus from here to here it is same distance plus central distance from here, which is equal to 5 by 2, so it is equal to 2.5 plus 2.5 is equal to 5 meter. Okay, so what is the center of gravity of this whole combination, common center of gravity of these two bodies? So suppose this is AG, so AG will be equal to W1 AG1 into AG1 plus W2 into AG2 divided by W1 plus W2. So everything is known to us. So W1 is W of rectangular portion, which is 686.7 into AG1 is 1.25 plus W2 is W of boiler 588.6 into 5, which is AG2 divided by weight, both weights 686.7 plus 588.6. so if you will calculate it, you will get it equal to 2.98 meter. So this is common center of gravity of this combination of two bodies. Okay, suppose depth of this is submerged in water. Suppose H is the depth of immersion H. So weight of these two bodies will be equal to weight of water displaced. Okay, so 686 plus 0.7 plus 588.6 is equal to volume of water. Suppose volume is below this portion only up to rectangular portion, so volume of rectangle is LB into H. So L is length is 10 into width is 7 into height we have assumed H, so this is volume, into weight density. So weight density is 10.104. everything is kilonewton, so we have kept it in kilonewton also. So H is equal to, if you add these two, it will become 1275.3 divided by 10 into 7 is equal to 70 into 10.104. so it will become 1.803 meter. So this is depth which is immersed in water. So what will be the distance of common center of buoyancy? Common center of buoyancy will be h by 2, because centroid of this portion which is submerged in water, so it will be h by 2. So common center of buoyancy, suppose it is BG, sorry, AB. Common center of buoyancy from A is h by 2, so it will become 1.803 divided by 2 is equal to 0.9015 meter. Okay, so what will be the BG? A distance between center of gravity of the combined shapes or weights minus the common center of gravity minus common center of buoyancy. So it is 2.98 minus, because we have calculated it, 2.98 center of gravity minus center of buoyancy is 0.9105. so it will become 2.078 meter. So this is BG. Now metacentric height GM is equal to I by V minus BG. So what is I? See, if you see in this figure, then you have to look from the upside, top view. So if you will see from the top, you will find out that it is a rectangular shape like this, and then there will be a cylinder, resting on it. But if you this is y axis, this is x axis, but which shape you have to consider for calculating moment of inertia? So you have to calculate moment of inertia and plan view or top view. So we have drawn it, and then you have to consider about y axis. So we have drawn it. At which level you will calculate for this cylindrical shape or this bigger rectangular shape? So we will calculate at the water level. So at water level, water is in this rectangular portion, there is no water touching cylindrical portion, so we will calculate for this rectangular portion, okay, because we have to calculate at water level. So I will be equal to BHQ by 12. so B, in this case this length will become B, so it is 10, it is 7, so 10 into 7 Q by 12. Okay, this is I. Now volume of water is equal to volume of rectangular surface which is submerged in water, rectangular body which is submerged in water. So length 7 into 10 into H. So 7 into 10 into height which is submerged, it is 1.803. Okay, so if you will put these values, then you will get gm is equal to I is 10 into 7 cube by 12 into divided by v is 10 into 7 into 1.803 minus bg we have already calculated 2.078. so if you will calculate it, then you will get gm is equal to 0.12 meter. So here metacentric height is positive, means metacentric height is above the center of gravity, means this is the stable situation. So in this case, this pontoon and boiler can float easily. Okay, they are in stable position. So I hope you understood this problem, and if there is any calculation mistake, then please let me know. And if you like this video, then please subscribe and share to our channel. Thank you for watching.